Today I'm going to be going over the Haber process, a reaction that is the basis of all fertilizer. First up, we're going to set up an experiment to show the effect of fertilizer on plants. We have 3 treatments with different amounts of fertilizer. In our control, we just have 100% dirt, which means there is no fertilizer. For fertilizer mix number 1, we have 50% dirt and 50% fertilizer mixed together. Each of the treatments will have 3 replicated plants. Lastly, for fertilizer mix number 2, that's 100% fertilizer mix. Next up, I dug holes and added my seeds, and I used these genetically engineered seeds so that they would grow a little bit faster. Next, I covered the seeds, added water, and set them in the sun to grow. Now, it has long been known by scientists that plants require 3 main elements for growth: nitrogen, phosphate, and potassium. There have always been adequate sources of phosphate and potassium, but there has only been one main source of nitrogen, which is Chile saltpeter, also known as sodium nitrate. This accounts for 60% of the world's supply. As a result, nitrogen has always been a limiting factor. With an increase of the global population and thus more food, we needed a new source of nitrogen. The Haber process was discovered by German scientists Fritz Haber and Karl Bosch in 1913 for the purpose of war explosives. Now, before explaining the Haber process, it's important to note that plants can't use nitrogen gas, but they must use fixed nitrogen such as ammonia or ammonium ion. This is why ammonia is the basis of all fertilizers. Now, this is the Haber process: 1 mole of nitrogen plus 3 moles of hydrogen to get 2 moles of ammonia. To manufacture this in the factory, nitrogen gas is obtained from the air, which is 78% nitrogen, and hydrogen gas is obtained from methane, CH4. Nitrogen and hydrogen gas is added in the 1:3 ratio, and an iron catalyst is used to increase efficiency. The Chatelier's principle is also used to increase efficiency. There are 4 moles of gas on the left and 2 on the right, so by lowering the pressure, the reaction favors the right, thus creating more ammonia. After the ammonia is created, the gas is cooled and the ammonia is turned to a liquid which is mixed with the fertilizer. Now, with any synthetic chemical, there are always drawbacks. The abundance of nitrogen creates an imbalance in the nitrogen cycle. And in the soil, bacteria may convert nitrate to nitrous oxide, which is a greenhouse gas. Heavy rainfall can also lead to excess runoff, causing ocean acidification as well as ocean dead zones. Lastly, the Haber process essentially prolonged World War I, since it provided an efficient source of explosives for weapons. While ammonia is the second most important chemical in the U.S., users of fertilizer, as well as people in general, need to consider the environmental, economic, and social implications of using ammonia to protect our Earth. So within a week of my experiment, unfortunately, my original 9 plants had not sprouted yet, so I went out and planted another 6 red kidney beans, and unfortunately they did not sprout either. So this was the final outcome. As you can see, there's not much growth at all. However, I did get 1 tiny clover in one of the fertilizer ones. While my experiment didn't work out perfectly, here are some other examples of experiments with a clear outcome.